For part 2 of our review, I'm going to look at the problems given to you on page 129. These are particle motion questions. So these are questions that are asking you to look at the relationship between the position function and the first derivative, which is the velocity function, and the second derivative, which is the acceleration function. So number 2 gives us a particle moving along a line that has a position for a time greater than or equal to 0, given by s of t equals t squared minus 3t plus 2. T is measured in seconds, and the position s is measured in meters. So part A asks us to find the displacement. And displacement is a measure of it's the difference between the ending position and the beginning position. In other words, where am I at the end? And that would be answered by s of 5. And then where was I at the beginning? That would be s of 0. And then I want to find the difference, so I'm going to subtract those. Please don't confuse this with the question, where am I at time 5? That would just be s of 5. We cannot assume we started at position 0 when we're at time 0. So mistakes that kids will make on this problem is they'll just find s of 5 and they'll forget to subtract. Alright, so that would give us 5 squared minus 3 times 5 plus 2. So that's s of 5. Now I need to minus, or subtract, s of 0, which plugging 0 in simply leaves me with 2. So then I can see I get 25 minus 15 plus 2 minus 2 cancels out, and I'm left with 10 meters. Part B asks me for the average velocity during those 5 seconds. So please don't confuse that with the instantaneous velocity, which is the part C question. So even if you accidentally answer the instantaneous, which is the derivative, on part B, I would hope that when you got down to part C, then you would realize your mistake. Some clues are that it asks for the average velocity, and average is a measure of something over time, or multiple parts, and instantaneous velocity is a velocity at a single point, or a single point in time. So part B, find the average velocity. Simply, how far did I travel? In other words, the displacement. So s of 5 minus s of 0 divided by how long did it take to travel. How far did you go and how long did it take? So I know from part A I went 10 meters, and I know that it took me 5 seconds, which of course gives me an answer of 2 meters per second is the average. So part C asks for the instantaneous velocity, and I know that velocity is the derivative of position, and that would be 2t minus 3. And I want to know what was my instantaneous velocity at time 4. So I evaluate this at 4, and I get 8 minus 3, and I get an answer of 5 meters per second. Part D asks me for the acceleration at time 4, and I know that acceleration is the derivative of velocity, or I could say it is the second derivative of position. And so I take the derivative of 2t minus 3, and I simply get 2. Evaluate 2 at time 4, and I get still 2. And this is going to be 2 meters per second per second. Alright, part E asks the question, at what values does the particle change direction? So changing direction would indicate a change in velocity. And so what we're really looking at is when did my velocity change signs, change from positive to negative or negative to positive. So if I look back up at part C, I see I have a velocity equation of 2t minus 3. And so what I really want to know is when did this velocity equal 0? And a quick solving for t gives me time 3/2. So I know at time 3/2 my velocity was 0. The question is, did it turn 0 and not change signs? Like, was the velocity positive and then 0 at 3/2 and then positive again? Or did it actually change? So really the best way to solve that question is to make yourself a quick little sign chart. And when I say sign, I mean SIGN. What are the signs of the numbers? I know at 3/2, at time 3/2, the value is 0. So what I need to do is plug in a value before 3/2, like maybe times 0. So I go to my velocity, 2t minus 3, and I plug in 0, and I see that my velocity was negative. Plug in a value bigger than 3/2, like 5 or 10 or a billion, and I see that I'm going to get a number that is positive. So what this tells me is at time 3/2, my velocity switched from negative to positive. And so the answer is yes, it changed directions, and it only changed directions this one time at, let's squeeze in a seconds right here. So time 1.5 seconds. And then part F. I'll put part F over here. Where is the particle when S is a minimum? So the evidence that we've gathered so far is that the velocity started off negative and went positive, which means on this little line that the particle supposedly is at, here's position 0. I know that I started somewhere at, actually I know exactly where I started. Let me change colors here. I started at 2, because at time 0 I'm at 2. So I'm over here at position 2. My velocity tells me, and plus the sign chart, that from 2 I worked my way negative for 1.5 seconds, and then I turned around and went positive. And so in this case, I'm looking for this location, because that is when I change directions and turn forward. Now, had we found lots of values on part E, then that would have told us maybe that I started and turned around and then turned around and then turned around again. We could have turned around a whole bunch of times. And then what I would need to do is I'd need to check my position at all of these places. But this was easy because there's only one. So I know that time 3/2 is when. The question asks where. So now it's just a matter of plugging in 3/2 for position and then getting my answer. And so a quick calculation here gives me S of 3/2 equals 3/2 squared minus 3 times 3/2 plus 2. 3/2 squared is 9/4 minus 9/2 plus 2. I'm going to get a common denominator across the board. So 9/4 minus 18/4 plus 2 would be 8/4. So that gives me 9/4. Negative 18 plus 8/4 is going to be negative 10/4. So it looks like I'm ending in a place of negative 1/4 meters. And just to again indicate what that means, at time 0 I was here at position 2, and then during the first 1.5 seconds I made it all the way here, my velocity turned to 0 and then back to positive, and I started moving this way. So this is negative 1/4 right there. I'm at 9 minutes on this question, so I'm going to go ahead and stop the recording, and I'll do problem 2 in a separate video.